Hello everyone, I am Sukesh from ECE. Today I am here to explain stretchable patches and devices towards electronics on the skin. Introduction. Wearable devices have attracted much attention recently as they are enable sensing in vinous manner. Various wearable devices integrate physical sensors such as accelerometer, thermometer, heart rate monitor, etc. have been commercialized. Example: Apple Watch, Jawbone, Fitbit, Jeans Meme, etc. Despite the current interest in and growth of market of the wearable devices, better information they gather a still rated limited integration of chemical and biological sensors into wearable devices will further advances are useful of wearable devices when are consider commonly used bands cannot ensure that tight contact with skin. Slickly gel pads are used for tight contact skin. It causes a occasional rash, wearing a discharging. Chemical and biological sensing efficient methods are shaping athletic and the key of the comfortable and tight. The key of secure and comfortable and tight interface between a device and the skin is biocompatible, stretchability, lightness, and stable adhesion to skin. Towards this
The key to
goal, our
success.
group is developing wearable devices that are entirely made of organic materials. Organic materials have advantages such as high biocompatibility, a variety of molecular structures for display properties, comfort for hearing. In this presentation, we discuss the two classes of technologies our group are developing. One, biofuel cells that generate power from biological molecules, microneedles that make efficiency of interface in the inside of skin. Here you show some pictures about the devices. Flexible and stretchable biofuel cells. Biofuel cells are used in enzymatic reactions to generate power from biological molecules. The output stability of BFCS shares have been significantly improved currently. BFC shares are becoming useful as a component for a self-powered wearable device. In addition to the roles as a power source, they can also work as a self-powered sensor as they have specified to the by choosing an optimal enzyme. For example, glucose oxidase selectivity use glucose as a substrate and locate oxidase use reactor power generation momentarily increase in substrate concentration increase. Our group developed flexible enzymic anode and cathode by coating carbonic fiber with carbon dioxide, followed by enzymic imitation as stretchable patches and devices towards electronic of the skin. Hiroki Kai Konaik and Nigmagi Master Department flexible and stretchable biofuel cell on a carbonic fabric coated one with CNCS structure dehydrogenous oxides fructose at an anode brilliant oxidize BOD reduces oxygen uptake at a combination of these two electrodes with electrolyte solution generates electricity. A layered flexible biofuel cell made of carbon fabric coated with CNC and enzymes and hydrogel containing fuel. A stretchable biofuel cell made of stretchable fabric. The figures are reproduced in 2 and 3. No, you can shift to figures. Robotic hand on one hand and some graph evidence. Ion top forces patch developed by biofuel cells. Our flexible viscous was integrated into a skin patch and during delivery with a direction flow of charger driven by electric system. Now another friend have to explain the remaining topic.
Hello ma'am, my name is P. Lokesh Reddy. I am the one of the member of in this case study. A mixture of a monomer, a porogen and cross-linker was photopolymerized in a flexible mold and peeled off to a fabricated microneedle array. Glycidyl methacrylate was used a monomer and polyethylene glycol as a porogen. Multifunctional acrylates were used as cross-linker fabricated porous polymer microneedles were observed by scanning electron microscopy, which showed interconnected pores with 1 mm diameter. We varied the volumetric ratio of the porogen in the initial mixture, and porosity of the fabricated microneedles was measured by immersing the fabricated porous polymer microneedles in water and measuring weight change. We define the volumetric ratio of the porogen in the initial measure as theoretical porosity and compared to the experimental porosity. The ratio between experimental and theoretical porosities should reach unity when all the pores by a porogen are connected each other and accessible from the microneedle surface. This ratio increases suddenly with threshold of porogen ratio at 30%, which indicates randomly distributed pores are more likely to be interconnected with increased density of pores. This paper explained our recent development of BFCs and porous microneedles that led to all orthogonal functional skin patches. Generated power of BFCs and its stability over time have been significantly improved recently, which made it possible to apply BFCs to medical and sensing application on a human skin. Novel attractive applications of BFCs promote the further improvement of BFC performance and vice versa. Porous microneedle can be a promising scaffold for efficient sampling and sensing of interstitial fluid due to their large internal surface area and fast absorption of water. Creative integration of these two technologies will lead to self-powered biomedical devices for health monitoring, drug delivery, etc.
Stop.
ఈ బొమ్మ గురించి ఏమైనా ఎక్స్ప్లెయిన్ చేయగలరా?